Okay, so a sample of radioactive isotope X is observed. Initially, the sample contains only isotope X. After 24 days, it is found that the ratio of the number of remaining nuclei of X to the number of nuclei of its daughter product is Y is 1:7. Calculate the half-life of isotope X. So right now, we know that the remaining nuclei X to the daughter product Y, which is basically the final decay product, is ratio to 1:7. This means that we can find the n, the original n, because right now they only give us two information, the ratio and the number of days, and we cannot use the number of days because it said that from the remaining nuclei sampai ke the decayed product is 24 days. So it could be from A to B to C, some is for 24 days, or it could be from A to B to C to D to E is durated for 24 days. We genuinely don't know. And we also don't know how many half-lives are there. We don't know from how many half-lives are there until the remaining nuclei. So C could be the remaining nuclei, D could be remaining nuclei. We don't know. We genuinely don't know how many phases it went through to become D. Okay? But what we know is that the remaining nuclei tambah the decayed is equal to the original nuclei. Why do I say this? Okay, hear me out. Let's say you have 100 students in a classroom. 40 students left to go to the library, and 60 students are still in the classroom. If I want to ask you, how many original number of students are there? You're going to tell me that you're going to take the number of students that are still in the classroom tambah dengan the number of students that left the classroom, right? So it's the same concept as this. So now that you hopefully understand that, we can take the remaining nuclei, which they give us the ratio is 1. We can take that and plus the number of decayed nuclei, which is the daughter product Y, aka the final decayed product, 7, plus, and you get 8. However, the problem is that we don't know what it represents. It's in ratio. It can be 80, it can be 8,000, it can be 8 million. But we do know that it's the original number of nuclei. So now we can substitute it in the formula because we know that n represents the remaining nuclei. The remaining nuclei. Okay? So because we have this two information, we can use it. Okay, we're going to utilize it. So 1 is equal to 1/2 power of n. And n is what? The number of half-lives. So after this, we can finally know how many phases that X went to get to the remaining nuclei. Okay. And then we take times with 8. Okay, so just simple mathematics. Okay, so now that we know that n represents 3 half-lives, do you think we can find out what the half-life of isotope X is? So it means that it went through 3 phases, and in order to find the number of half-life, we have to take the total number of days, which is 24, divide by 3. So then you get